Tonight we're going to be looking at linear inequalities. Remember back when we looked at inequalities in the past, I had you graph them on a number line like this. So when x was less than 1, I drew an open circle around 1, and it was all the points to the left of 1 that made this true. In a similar way, we're going to look at how to graph this on a coordinate plane. Now, similar to how I had an open circle at 1 when it was less than but not equal to, I'm going to end up graphing this using a dashed line. Remember, I find where x equals 1, and x equals 1 is a vertical line, but it's dashed because it is not equal to 1. What this means, again, when I have left, everything to the left of 1 is a solution, less than and left. So here I'm going to highlight everything on my graph that is to the left of my dashed line. So it looks something like this. Now, if I had something that looks like x is greater than 1, I would end up graphing that by, again, an open circle on 1, but this time it would be everything to the right of my number. That would be a solution. So again, it would be a dashed line at 1 because 1 itself is not a solution, it's everything greater than. And I would highlight everything to the right of my graph, or the right of my line. Let's look at identifying some new terms for you. A linear inequality describes the region of the coordinate plane that has a boundary line. If I look back over here at my graph, my linear inequality is talking about a region. Here, the pink region was the region that was less than. My green region was the region that was greater than. And it has a boundary line. Here, my boundary line is dashed because it's not actually equal to 1. It's greater than or less than. And the solutions of an inequality are the coordinates of the points that make my inequality true. Here, I could take any inequality, any points in my green section. I could take 3 and 1. I could take 5 and 3. I could even go way over here and take 6 and 10, and they would be a solution to the inequality because they would make the equation true. All right, let's look at this and think about plotting lines. Sometimes I don't have numbers like I do above, or I have y's and x's. Actually, generally, this is going to be my situation. In a case like this, here I have y is less than x. I can't graph that on a number because I don't have any numbers, but I can graph it on a coordinate plane. Let's think first about making this into a function, something like y equals x. And let's plot that. Remember, that's the same as an intercept of 0 and a slope of 1. So when y equals 0, x equals 0. And it goes right on these points. Up 1 over 1, down 1 and over 1 to the left. So my line is going to look something like this. Now I need to go back and double check. Was it less than and equal to, or just less than? It was just less than. So I need to be very careful here, and I need to create a dashed line. So I'm going to go back and I'm going to erase some parts of my line. Make sure you're doing this on your line too. Okay, once I have my dashed line, then I'm going to shade. And if it's less than x, think about this. Is it going to be the areas up here or down here? It's going to be the areas below. Good. All right, and here's why. Let's take a point. Let's take 2 and 2 because that's really squarely inside my pink shaded area. And let's just check. Y is, at this point, y is 2. And x is 2. Y is negative 2. Is it true that negative true is less than 2? Yes, it is, so this point works. It's a good way to check your shading. Always choose one point that's clearly in your shaded area and plug it back in your inequality. Let's do the green area. Your line is going to be exactly the same. It's a slope of 1 and an intercept of 1. Remember that my first step is always to think of this as y equals x and plot the line. The next thing to do is to shade my line. Now, if it's y is greater than x, then I need to do everything above my line. And when I have stuff above my line, that is where y is greater than my x. Let's think about checking this with a point. Let's come back here and let's look at -2 and 2. At -2 and 2, y is 2 and x is -2. And my inequality said that y was greater than -2. Is that the case? -2 is greater than -2, yes. So this is the direction I plot my inequality. All right, let's look at practicing these. All right, we're going to look at graphing y is less than 2x plus 3. And we're going to do this through the following 4 steps. The first thing that we want to do is we want to turn our inequality into an equation. So we're going to take y is less than and make it y equals 2x plus 3. And we're going to graph this. And remember, I graph this by starting with my y-intercept. That's over here. And I have a slope of 2, which is the same as up 2 and over 1, and down 2 and over 1. And I'm going to go all the way to the end of my graph here. So this should be my line. All right, I've graphed my line. The next thing I want to do is I want to check to see if my line equals, if it is equals to or not. So let's come back up to my inequality here. Do I have an equals? No, it's just everything less than. So now I need to check my line and I need to fix it. If it's not equals to, then my line needs to be dashed. So I need to dash this line. All right, now what I need to do is I need to shade. And remember, if it's a less than scenario, I'm going to end up shading everything under my line. And then the next thing that I want to do is I need to check my equation. Check by substituting a coordinate. So let's pick one that's squarely in here. Let's do 3 and -3. That's in the shaded area. And I'm going to go back to my inequality. And I'm going to say if y is less than 2x plus 3, and I'm looking at the coordinate 3, -3. Is -3 less than 2 times 3 plus 3? Well, -3 is less than 6 plus 3. -3 is definitely less than 9. Yes, the direction of my shading is correct. All right, let's see, what happens if you have a graph first? On your own now, I would like you to graph y is greater than or equal to 3x minus 1. Make sure that you check your line, you shade, and you check your work. You should have all 5 of your steps and your graph on your own paper. Now, what if I'm given an equation like this and I'm told to graph it? I have to graph an inequality, but I can't easily graph this. It's in standard form. In order to do that, I have to solve for y. So I'm going to move 3x over here, and I'm going to end up with -5y is less than or equal to 10 minus 3x. I'm not done yet. I now have to divide by -5 and divide over here by -5. And watch this. You got to be careful here. You divided by a negative. So you now need to switch your inequality. And furthermore, you now have to split up 10 over -5 and think about -3x over -5. You have to distribute this constant down here. So now I have y is greater than or equal to -2 plus 3/5 x. At this point, it's not pretty, but I have point slope form. Once you've rearranged, you recognize that this is your y-intercept and this is your slope. And now I can continue with those 5 steps. Remember that the first thing that I want to end up doing is to rewrite my inequality as an equation and graph it. So I want to think of this as y equals 3/5 x minus 2. So I end up with the y-intercept here and a rise of 1, 2, 3, and a run of 1, 2, 3, 4, 5. And again, down 1, 2, 3, and over 1, 2, 3, 4, 5. And this is my line. Okay, once I've graphed my line, I needed to go back and check. Is it a greater than and equals or just greater than? It's equals. So because it equals, I can leave my line. I don't have to make it dashed. Now I have to shade. And because it's greater than, it means everything above. So you shade in your line. Then we're going to find one point here, and we're going to check. Let's take 0 and 0. That point's easy. It's squarely in the shaded. Is it true that 0 is greater than or equal to 3/5 times 0 minus 0? Well, that just becomes 0 is greater than or equal to -2. Is it true that 0 is greater than -2? Yes, it is. So I know that my shaded direction is correct. This is helpful, and if you didn't remember to switch your inequality sign way back here in this first step, you would have caught yourself and you would have shaded the red area down here, gone to check your point and said that doesn't equal. So you would have come back up here and said, oh, I solved it wrong up here because my inequality didn't switch when I divided by a negative. Always, always, always pick a point in your shaded area and check your work. On your own paper, using this format, I would now like you to complete this problem. Remember to solve for y, show your work, and go through all 5 steps to graph this inequality. Solving these systems and using inequalities, it can actually be really helpful when we have word problems in real life situations. Suppose you're planning a party and you have a budget. You don't want to spend any more than $12 on peanuts and cashews. Peanuts cost $2 a pound and cashews cost $4. I've got a variable here, peanuts, that's $2 a pound, and I've got cashews and they cost $4 a pound. I want to find 3 possible combinations of peanuts and cashews that I can buy. And remember, let's go back up here. I can't spend any more than $12. No more than 12. This is some sort of inequality. Is it greater than 12?
For 5 pounds of apples?
Or is it going to be a situation where it's less than 12? Well, if I don't want to spend any more than 12, 12 is the absolute most that I can spend, then it's going to be this direction. Now let's think, can I spend $12? Yes. Do I want to spend $12.01? No. So it is a situation like this. I can spend 12, but I don't want to spend any more than 12. So peanuts cost 2 pounds. $2 a pound, I'm sorry. So I have $2 times P, and cashews cost 4. And somehow, some combination of peanuts and cashews has to stay within my 12. By the way, I'm spending money. Can I spend less than 0 money? No. So this is also a situation where I've got a boundary. So think about this on a number line in terms of the dollars I have to spend. I can spend up to 12, 6, 4, 2, but I can't spend any less than 0. So I have to spend something within this amount. So I've also have to do it greater than or equal to 0 because it has to be realistic. So just keep that in the back of your mind as you're solving. Let's look at setting 2p and 4c as less than 12. And let's think about this as write an equation. Let's make this an equals scenario. And suddenly I have something that looks a whole lot like my ax plus by equals c. It's standard form. So which one do you want your y to be? Well, I like division by 2. So let's choose to move my 4c. I'm going to move it on both sides, and I get 2p, these cross out, equals 12 minus 4c. Okay, not too bad yet. Let's divide this by 2, this whole side, and I get p equals 12 divided by 2. Remember to split this guy both directions. Bring your sign down in the middle. 4 over 2c. So I end up with p equals 6 minus 2c. It's still not quite in the right form, so let's do a little bit of rearranging here. P equals negative 2c plus 6. Remember, bring this whole guy over here, and this guy over there. Now this is in the form y equals mx plus b, and this is really easy to graph. So knowing that this is in the form of y equals mx plus b, b is my y-intercept, so that's right here. And of course I chose a graph where that's not even on here. Hold on. So my y-intercept is at 6, and my slope is a negative 2c. So let's do up 2 and over to the left 1, up 2 and over to the left 1, or down 2 and over to the right 1. So I get a graph that somehow looks kind of like this. As I'm relating the cost of my x here, which is my c, or my cashews, and my y-axis is my peanuts. Okay, so if I remember correctly, this was a situation where I had a less than or equal to. So let's go through. This should be less than or equal to, less than or equal to, less than or equal to. Did I divide by a positive number? Yes, I don't have to switch my sign. Okay, so which direction is my inequality going? Well, p is less than or equal to. So since it's equal to, I have a solid line. I'm good there. But now I need a shade. So it's everything less than negative 2c plus b. I want you to see this really carefully, though. It's everything to the left of my line, right? Okay. Yes, but I'm talking about dollars. Can I spend less than $0? No. So at some point, I have a boundary on here, and it's going to be everything in between my positive and negative y's, because I can't have negative peanuts and I can't have negative cashews. So if I zoom in here on my map, I need this area in between where everything is positive. And if you do this with a highlighter, this area should turn green if you go over it with blue. So I want this area. This area right here, this triangle shape, is the set of combinations I could have within my $12 budget, because I can't go negative. It has to be above 0. So if it has to be above 0, then let's go back to my question and see if I can answer it. I want to find 3 possible combinations of peanuts and cashews I can buy. So pick any 3 areas within my shaded area. I could pick this point right here. I could pick this point, or this, or this. Again, remember, I don't want 0. So if I picked this guy right here, it's how many cashews? Well, that's at 1. So it's 1 cashews, and how many peanuts? 1, 2, 3. Okay, what if I picked this guy right here? What's that combo? Well, it's 2 cashews and 1 bag of peanuts. Okay, let's come over here and let's look at 1 on the line. I can pick 1 on the line because it could be equal to. So let's check this guy. Is it possible I could have 2 bags and 2 bags? 2 cashews and 2 peanuts? Yes, it is. All of these are potential. These are 3 possible combinations I could buy. I could buy 1 bag of peanuts and 3 bags of cashews. Or I could buy 2 bags of peanuts and 2 bags of cashews. Or I could buy 2 bags of cashews and only 1 of peanuts. Notice I could also elect to buy only peanuts or only cashews and still be within my boundaries of $12. All right, hopefully this showed you how to solve some word problems. I'd like you to do this on your own now, and I would like you to solve this problem. All right, copy this problem down now, and let's solve this and graph it, and make sure that you answer the actual question it's asking, and I will see you in class tomorrow.